Hello, this is Greg Bukowski, and I'm going to record a video today on a very simple model training and running the model into production, referring to a data mining model. I'm focusing on something that's quick to get started, not assuming you have a lot of knowledge or background already, and also I'll skip the big data infrastructure. Later on in other videos, I'll start adding up some big data infrastructure and make things increasingly more complex. So the steps I'll go through in this video is find a public data set for training the predictive model. We're going to load it into R using the Rattle package. Rattle has a nice GUI that's very easy to use, and it'll help you get through this quickly. Train a basic decision tree model, and we'll score the data. So scoring means we'll create a new field that has the forecast from the decision tree model for every record in the data set. Now we're going to save it as a PMML file, Predictive Modeling Markup Language file. PMML is a type of XML. It's exported by about 18 different data mining packages, and you can read it into about a dozen packages or software systems that execute PMML, including Khamanja. So today I'll be talking about running the PMML model in Khamanja. And like a common situation when you've changed code, going from the model development to the production, it's always good to validate in QA. And so we'll be comparing the scoring data, expecting an exact match. So that's an overview of what we're going to do. Let's see, I've covered some of the objectives. This is a note file. So shortly I'll tell you how to get the note file. And that way you can have all the details in case something's not real clear from the video recording. So I'm aiming this at data miners, people that may know other tools or languages, but maybe not R, or maybe you do know R very well. I'll tell you how to get to the generated R source code. I will try and help you to easily get started with R. Or also, there's others who want to get started with hands-on data science practice, then this can complement some other training you're probably going through. So welcome aboard. We need 100,000 more data miners for this year and next that we're already short on. So the supply and demand is there. So I would prefer if you've already installed the R package, but I'll give you some brief instructions. Let me see. I'm kind of expecting that you have some experience in modeling and you understand some of the basics of the modeling, or you'll get some training in other places. I'm not covering that now. I'm doing this demo on a Mac, and I expect it's easy for you to get to a Unix command line terminal. And I'm not trying to make the best or even a good model. I'm just doing one common use case workflow to go through there. And then later on you can iterate and go through and change things. So I told you I'd explain how to get to the demo notes. So for your convenience, I set up an environment variable. Let's see, we'll go to a terminal. And then I'll edit nano. So if you've already installed Khamanja, then you probably have many of these set up. Right now, the two environment variables that for this particular video, I want you to do is this vid1, and that'll be our working subdirectory. So that's put it somewhere under Khamanja demo and then video 1. Later on, we can have video 2, video 3 under Khamanja demo as well. And then this particular data set that we're going to end up getting is autos mile per gallon. So set up that environment variable as well. Let's see, so once you set that up, as you can see on the bottom, write out is Control O, and then X, Control X, that's for exiting. Then source tilde dot profile, and then we should be set up. So to get the notes and other things, then go to this tiny URL. Okay, so here's a tiny URL. And I usually like to do list view instead of the blocky stuff. So this is where we're going to have the series of training videos. So there's been video 0, some PowerPoint slides, just general background in motivation on doing this faster model deployment and talking about that. So this is the first video, simple model into production. So going into here, so we want to get this execute pmml.jar, click on that, and then click on the download. I won't download it this minute since I've already downloaded it. And you also want to get the PDF notes that will describe, the notes here I have on the left that I'm going through. So you want to get those and download them. And then for the execute pmml jar file, you either want to save it directly to the Khamanja home bin, or else you want to copy it from the download directory, which is where things go to by default, to the Khamanja home/bin. In my notes, I describe what some of the subdirectory structure is. And then also on the Google Drive, if you would click the Add to Drive button up on the top right, then next time you come into Google Drive, logged in under your Gmail account, on the left margin, you can click on this Shared with Me, and then you'll just see the directory name Khamanja demo. And that'll make it easy. You don't have to remember any tiny URL link anymore. So if needed, then next you can install R and Rattle. So let's see. Go to R, and you get to the R project for stat computing. So R is a statistical language. So go to this download R link, and then they have different locations. I'm going to search for something in the US. So just a quick Control F, USA, go down here. And then I'm running on a Mac. You can choose Linux or Windows as you like. So then go ahead and run that install. I also suggest that you install RStudio. So RStudio is a good integrated development environment. RStudio download. Click. And then in here you can go to the installer for the operating system that you're using. So go ahead and do what's appropriate for your system. So now, I did have in the Google Drive the data set, but I wanted to teach you how to fish so you can feel comfortable going around getting other data sets. So there's one UCI machine learning repository. So I'll copy that and we'll search for it. Okay, we found it. View all data sets. So you can see this has about 300 data sets to choose from. So each one of these could be a different data mining problem. I'm going to choose a regression. I want a continuous target. It's very common for predictive models to be predicting like a future dollar value or a risk probability. So those would be continuous targets. So click on the regression. A lot of times you'll have a mixture of categorical input fields and numerical or continuous. So I'll choose mixed. The first one that comes up is this auto miles per gallon. That one is small, 400 records, and 8 input fields. It was contributed in '93, so it's not going to have any current cars. But that's okay. It's something easy to get started with. So in here, it has some description of it. Yes, it does have missing values. And it describes what the attributes are. So miles per gallon is what we're forecasting. And then it has the names of the 8 other fields that are in the data set. So if you work on building a couple different models and you want to see how other people work with this data set, then they have a bunch of other papers listed here that have worked on that data set. Well, let's get to our data. So I'm going to click on the data folder here. The auto miles per gallon names is here, so you can save that. And then there's also auto miles per gallon data. So I'm just going to go through and Control C to copy it all. So what I want to do is I want to convert it into a CSV data file, just to make it fairly general and easy to work with. I'm trying to minimize complexity in what might be new tools to you and just stick with more common things like editors or worksheets. And I notice there's a question mark here, so that's probably what the missing data is that they mentioned. So let me see. I will do File, New Workbook. And close out this one. So I'm going to go one row down because we saw at the top it didn't have the field names. Oh, not that again. Control C, Control V. Okay, there's the data. And then here I'll get the field names from my notes file. So my notes, I got a screenshot of that. And let's see. Here are the field names, miles per gallon and so on. So that's an easy way to copy it. Just paste it here. Control V. I'll get rid of some of the leading spaces. So now I want to convert this to all the data in one column to have the data parsed out to however many columns of data there are. So go to Data, Text to Columns, Delimited, Next. Okay, so make sure space is checked. And then you can see here, just to check your work, that it's would be delimiting it as expected. I'll just click on Finish, and there the data is set up here in the worksheet. So next I'll work on just doing a missing value substitution, or using average values for missing values. So first we have to figure out which fields have the missing value. So I'll use an Excel function COUNTIF. The reason I'm doing it here as opposed to the data mining packages is in this first video, I wanted to keep things real simple in the other packages. Equal COUNTIF. So we're counting through these number of cells, whatever equals a question mark. Okay, so there's no missing in miles per gallon. I'll copy it across. And we see, 6. So there's 6 missing values of horsepower. So we know that they're missing. Let's figure out what the average is. And we'll use that to replace the question marks. And select a range, return. So it's 105.5. So now I'll select just those records to be replaced. So I'm going to use a data filter. And then I want to not select all the values. I just want to select the missing value or question mark. And then this lists the horsepower. And if you want to see the attributes or like what the cars are that have missing horsepower, maybe you want to look up and put some better values in than the 105.5. So 104.5, copy and paste. Okay, so I'll turn off this filter. And before I save this as an external CSV file, I'm going to get rid of some of the junk below. So I'll just do an edit, delete, and then now I'll do a file save to convert it to CSV, save as. And then down here in the Excel workbook, going down to Windows, comma separated. Don't use the other one. Focus on the Windows, even if you're on the Mac. And then navigate to your Khamanja demo data auto MPG directory that you created earlier. And we'll save this as auto MPG and leave the CSV extension. Save it. And it's asking me if I want to replace Since I've done the demo before, I already have it. So I'll just go ahead and replace it. Hit continue. Okay, so now I've saved that data. There's a documentation for those steps. Okay, so now to get into Rattle. So I'll come over here, and then I'll run Rattle. Right. Load the package into memory. I've got two screen systems, so things pop up on my other screen. And so this is the main user interface here for Rattle. Okay, so what we're going to do is, kind of goes on these tabs from left to right as you would typically go through in a project. So this first data tab is checked. We are reading a spreadsheet or CSV file. It is comma delimited. So let's browse through, find the file in the file name browser. So I'll go to my directory, desktops, Command demo, data R is AutoMPG, and then if you were to use other kinds of files, here's some of the formats that you could use. For now, I'll leave it as CSV. Click on Open. Okay. And then now we're going to execute or run that. And so once we hit execute, then it shows up with what the fields are. And it's making some guesses, but we need to correct some of the guesses. So for example, the target is not origin, the target is miles per gallon. So we'll click on that. And then all the other fields are generally inputs, but car name, that's not going to be an input. So we'll click ignore for that. And this looks like the screenshot I took for you. Okay, so now we're going to go ahead and execute this again. Now that we've set the different roles for the variables. Okay, and we can also go save, and then let's see, Greg Makowski, documents, Command demo, and I'm going to save this in video 1 folder because that's my working directory. And then I'll click save down here. Okay, so that's saved. Before I go any further, never want to lose work. Okay, so now I want to train the file. So I go over to model, the type that offer decision tree, random forest, linear, which is regression, neural net. So I'll do decision tree this time. So for the minimum split, I'll get a little bit more aggressive. Instead of having to have a minimum of 20 records in a node before I'll consider splitting it all, I'll go down to 9. And here it's saying the model builder is the package rpart for recursive partitioning. That's the decision tree package in R. So I've set that up. Down here, let's see, I'll go ahead and execute. And so now it shows we have the decision tree. There was 278 records in the training set. Remember, we did that split when we loaded the data between training and testing. So here it's showing if displacement is over 190.5, then it will be forecasting a horsepower of 16.9. And if it's this displacement and this horsepower, then it forecast 14, this displacement and this horsepower, and to forecast 19. So this is what the output is for that. Okay. And let's go ahead and take a look at the data. Oh. and look at some top number of fields. Okay, and so here you can see it is comma separated, and that's the fields as we expect. The rightmost field is car name, and that certainly makes sense. Okay, so I've trained a model, looked at the model results. Now I want to score the decision tree or apply it. So this is the evaluation. So different ways you can evaluate would be creating a risk, or I'm going to choose score. So that means just output the particular score values. We're going to train on the tree, and let's see, I'm going to do full because I want to score all of the data between training and testing. And I want to include all fields. Identifiers would be like key fields, like social security number or something. All fields includes all the inputs. I was just doing that because it's both a small data set and it just makes it less confusing because you can validate what's coming out and you can compare the forecast versus the actual. Okay, so now I have checked that data, and then it's asking where do I want to store the scored data. So I'm going to use the AutoMVG and then R part for recursive partitioning. Oops. Okay. I see I did export to export the scored data. Well, that's something I want to do. So I'll save that in the video. And I'll save the CSV file as a rpart.csv. And then I'll export the PMML. So let's see, I'll go back to the model tab and then the export button. And then to the video one. And then we have the type of PMML. PMML is a subset of XML. And so we'll just use this default name. Let's see, save. Okay, so we've done a bunch of stuff in our rattle. Also on the far right is the log file. So this has all the generated R code. So if you're an experienced R user, you can start here. I'm sorry, if you're new to R and you want to just run things at the command line, then you can kind of copy and paste it from here. So, and this is also in the appendix. Now we'll get into running CMONJA. Okay, so go back to my terminal. Go to the video directory for this particular video. Okay, so here you can see in this that it's got the PMML file here is this XML. It'll have the input CSV file, and then we're going to create an output rattle file. So, an output CSV. In here, this is the command to run it. So we're running in CMONJA home binary, this execute PMML jar. And it takes as parameters the model and the model name. And then the input data set and the output data set. I'm just going to copy this, save myself some typing, and hey, I gave you the note file. You can copy it too. No one's a fan of lots of redundant typing. Okay, so I just ran this, and then now let's take a look at the results. Let's see. Whoa, sorry about that pause there. Um, okay, so I ran that and I want to take a look at the results. Hmm. Oh, I know. I didn't have the right path for the data set. Since the last time I gave this demo, then I split it up. Okay, that should run it okay. Okay, I'm getting a little tired today. Put that in the wrong place. It should be the data set, not the model. The data set is in the data directory. Okay, no error messages. And we see the K scored. Okay, so that's good. So now let's take a look at that. Head. Oops, I want to do 25. Look at the top 25 records. And then we can see we had the same score values, 14 miles a gallon for most of it, coming down to, like this Volkswagen was 31 miles a gallon. So that's most of my demo. So thank you very much, and I'll talk to you later. How do I stop this?